Okay, this will be the last thing we do with trig. Let's solve some hard trig problems. Suppose you have b sine kx plus c plus d equals a. This is the key thing here. They're giving you some sort of algebraic expression as the argument of sine. First thing you want to do is transpose this. In other words, let's get sine of whatever all alone. That means I could subtract d from both sides. When I do that, if I subtract d from this side and I subtract d from this side, I can divide by b and I'll wind up with sine of kx plus c is equal to a minus d, and then I have to divide this because it's times b, to divide both sides by b, and I get a transposed equation. Now, the problem here is we've got an algebraic expression there, and that's not going to work for us. So we're going to substitute this for theta. And that will allow, if we consider, we can also simplify that, and we call that m. So if it's 10 minus 4 divided by 3, we can call that m. So if kx plus c is theta, then this will give us sine, instead of kx plus c, I'm going to write theta equals, instead of a minus d divided by b, I could simplify that and just come up with some answer I'll call m. Now I can solve this. How do I solve this? Well, theta would equal sine the inverse of m, or arc sine m, which will give me theta equals some answer 1, some answer 2, some answer 3, etc., etc., etc. Once I get that, once I get my several different answers, as we've seen, this is a periodic function, it's going to give us many answers, depends on what our domain is to see how many answers we're going to get. We can now substitute back, because I said that theta was equal to kx plus c, so now my theta, which was equal to theta 1, I can say, instead of theta, I say kx plus c equals theta 1, so x, which I want to solve for, is minus c from both sides and divide by k. Theta 1 minus c over k. Here I get theta 2 minus c over k. Here I get theta 3 minus c over k. The important steps are transpose and then substitute for whatever your argument of the sine is. Solve that and then substitute back to solve for x. Let's see how one of those works. Okay, here is an example of one of these hard problems. Here is our problem. 4 cosine 2x plus 4 plus 3 equals 7. This part makes it particularly hard that we don't have just a theta or an x or something. We've got an algebraic expression in there. First step, plus 3, minus 3 to both sides. Then divide by 4, so I get 7 minus 3 over 4 gives me 1. I get this expression, cosine of 2x plus 4 equals 1. I'm going to here's my key step, I'm going to let theta equal 2x plus 4, so I can write this as cosine theta equals 1. Where does cosine, or the x coordinate, equal 1? Right here in my unit circle, that's at 0, 2 pi, 4 pi, 6 pi, etc. if I consider going the counterclockwise positive direction. Or I could solve with my calculator, provided I'm in radians, and I'll get theta equals 0, 2 pi, 4 pi, etc. Well, I don't have theta. Theta is this. So I substitute back 2x plus 4 equals 0. So x equals negative 2. 2x plus 4 equals 2 pi. When I solve that out, I get x equals 1.14. 2x plus 4, instead of theta, 2x plus 4 equals 4 pi. And when I solve that, I get 4.28. How do I know those are my only 3 solutions there? Well, one thing we can do is we can look at the domain. I know x is between negative 2 and 5. But I want to know, where is theta? Well, theta is equal to 2x plus 4. So if x is between negative 2 and 5, what is 2x plus 4? In other words, I'm saying something like this. Well, theta is also... I know the domain is restricted for x between negative 2 and 5. I also know that 2x plus 4 is equal to theta. That means if I solve for x here, that I have theta minus 4, divide each side by 2, I'll get x is equal to this. Well, if x is equal to this, I can make this statement. Negative 2 is less than or equal to theta minus 4 divided by 2 is less than 5. I can multiply both sides of this by 2, and I'll get negative 4 is less than or equal to theta minus 4 is less than or equal to 10. I can add 4 to both sides, and I get 0 is less than or equal to theta is less than or equal to 14. Well, that will guide me here when I'm looking, what is theta equal to? Well, I know that theta is going to be between 0 and 14, so I can solve this way. I know I'm not going to have any negative values of theta, so I can go to 0 and then 6.28, and then this is going to be a little less than 14. So I know that these are my only solutions because my theta must be between 0 and 14.